There is an island on the western edge of Europe where the past never fully left. For most of the continent, the Bronze Age is something buried, a layer beneath later invasions, later languages, later kingdoms. But in Ireland, geneticists have found something stranger. A population where the deep past did not just leave traces. It left a signature still visible, still measurable, in the DNA of people alive today. If your family carries a name like O'Brien, O'Neill, O'Sullivan, McCarthy, O'Donnell, O'Connor, McNamara, O'Reilly, O'Toole, McDermott, O'Kelly, or O'Malley, names that trace back not to a village or a job, but to a chief, a dynasty, a kingdom, researchers suggest you may be carrying something far older than a family tree. You may be carrying a genetic fingerprint of the very Gaelic power structures that once ruled the island. This is the story of how ancient DNA quietly rewrote what historians thought they understood about Irish ancestry, and why one particular finding, buried in a set of Bronze Age bones, forced scientists to ask whether Irish history had been building toward a single genetic event all along. For a long time, the accepted story of Ireland's population was one of layered invasion. Ancient chroniclers and later, Victorian-era historians described wave after wave of settlers arriving on the island, early farmers, then Celtic-speaking groups arriving from continental Europe sometime in the first millennium BC, bringing with them the language that would become Irish, along with new social structures, new elites, and new gods. This Celtic arrival model treated Ireland the way much of Western Europe was treated, as a place shaped primarily by successive migrations sweeping in from the east. It was a reasonable framework. Irish is a Celtic language, closely related to Scottish Gaelic and more distantly to Welsh and Breton. Shared mythology, shared artistic styles, and shared archaeological patterns across the Celtic-speaking world all seemed to support a common continental origin. The story held together. It explained the language. It explained the legends. It gave Ireland a place within a broader European Celtic narrative. But the story had a timing problem that few people noticed until archaeologists and geneticists started comparing notes more carefully. The genetic and archaeological signatures typically associated with Celtic material culture in Ireland don't cleanly align, in timing, with the massive ancestry shift that DNA studies later revealed. The population upheaval shows up earlier, during the Bronze Age, not clearly tied to the classical Iron Age Celtic period historians had long assumed was the turning point. Something significant happened in Ireland's ancestry. But it happened before the story historians had been telling was supposed to allow for. That mismatch was the first crack. This is where ancient genome sequencing entered the investigation. Not modern DNA alone, but actual extracted and sequenced DNA from human remains thousands of years old. Researchers, most notably a team led by geneticist Laura Cassidy at Trinity College Dublin, sequenced the genomes of ancient individuals from Irish archaeological sites, including a Neolithic woman from the Passage Tomb at Newgrange and a set of Bronze Age individuals from Rathlin Island off the northern coast. Autosomal DNA, inherited from both parents, allowed the team to estimate broad ancestry proportions. Y-chromosome DNA, passed father to son, let them trace male lineages with unusual precision. And when they compared the Neolithic genome to the Bronze Age genomes from the same island, the change was not subtle. The Neolithic population of Ireland, the study found, carried ancestry overwhelmingly derived from early Aegean and Anatolian farmers, the same broad ancestral stream responsible for megalithic monument builders across much of Atlantic Europe. But by the Bronze Age, roughly 1,000 years later, the genetic picture on the very same island had shifted dramatically. A substantial proportion of Bronze Age Irish ancestry now traced back to populations connected to the Pontic-Caspian steppe, the same eastern migration wave that had already reshaped the ancestry of much of continental Europe. That was not a contradiction. It was a signal. Ireland, an island historians had long treated as a remote endpoint of migration, had absorbed the same transformative steppe-related ancestry that swept the continent, and it had arrived earlier than the Celtic invasion story had accounted for. If stories like this catch your attention, where the evidence doesn't just support the old timeline, but quietly moves it, this is exactly the kind of investigation worth following, because the deeper layer is still ahead. Researchers have proposed several frameworks to explain what this ancestry shift actually represents, and it is worth saying clearly, this remains an active, evolving area of study. One framework treats it as a large-scale migration and replacement event, in which incoming groups carrying step-related ancestry arrived in sufficient numbers, over generations, to substantially reshape the island's gene pool well before the classical, Celtic, period historians had assumed was the pivotal moment. A second framework proposes a more gradual, multi-wave admixture process, where successive smaller migrations across the Bronze Age slowly diluted and merged with the existing Neolithic population, rather than one dramatic replacement event. A third framework, still provisional, connects this genetic shift to the introduction of specific Y chromosome lineages that later become strikingly dominant in Irish population history, lineages that some researchers argue may be connected to the rise of specific ruling dynasties centuries later, though this link remains carefully debated rather than settled. That third framework is where the story reaches its most striking evidence. The landmark moment came when researchers studying Y chromosome data across modern Irish populations identified an unusually high frequency of one particular paternal lineage, a genetic signature disproportionately common among men bearing certain Gaelic surnames historically associated with medieval Irish ruling families, most prominently those linked to the Ui Neil dynasty and the legendary figure Neil of the Nine Hostages. A 2006 study led by geneticist Daniel Bradley at Trinity College Dublin, examining Y chromosome markers across Ireland and Scotland, found that this lineage appeared at strikingly elevated frequencies in men carrying surnames tied to septs historically claiming descent from that dynasty, frequencies far higher than chance would predict, and consistent with a single, unusually successful paternal line expanding rapidly across the population over roughly the last 1,500 years. This is where the twist truly lands. Not simply that Ireland had absorbed outside ancestry, the way nearly every population in Europe had. The surprise was that a single, specific male lineage, connected, however cautiously, to a real historical dynasty remembered in the earliest Irish annals, appears to have expanded through the population with a scale and speed rarely documented so clearly anywhere else in Europe. The genome was not simply recording migration. It appeared to be recording power, the reproductive success of a ruling line, echoing forward through 15 centuries of Irish genealogy. Not the invasion story historians had built their timeline around. Something closer to a dynasty's biological footprint, preserved not in a chronicle, but in the Y chromosome of ordinary men living today. This matters far beyond Ireland. It is a reminder that history is not only written by kings, sometimes it is carried by them, silently, across generations, long after their kingdoms have dissolved into legend. Surnames that once marked political allegiance to a ruling sept may, in some documented cases, also mark biological descent from it. Not always. Not for every name. But often enough that geneticists could detect the pattern statistically across an entire national population. It also reframes what Celtic Ireland even means. The language, the mythology, and the material culture may indeed trace to Iron Age developments. But the deep ancestry beneath all of it, the biological substrate the culture was layered onto, appears to trace to an earlier, Bronze Age transformation that had nothing to do with the Celts at all, and everything to do with a step-connected migration that reshaped the entire western edge of the continent centuries before anyone in Ireland spoke a Celtic language. Picture the Rathlin coastline where those Bronze Age remains were found, basalt cliffs dropping into cold Atlantic water, seabirds wheeling over a narrow channel that separates Ireland from Scotland by barely a few miles of open sea. It would have looked, to those Bronze Age settlers, less like an edge of the world and more like a crossing point. A place where boats moved easily between two coastlines, carrying not just goods, but people and the ancestry they carried with them. Inland, across the peat bogs and limestone valleys that would one day be divided among Gaelic kingdoms, the descendants of those same migrants would build the ring forts, raise the cattle, and eventually establish the ruling families whose names, astonishingly, survive in the Y chromosomes of their descendants today. The old story imagined Ireland as an island waiting at the end of a migration route, absorbing the last ripple of continental movement. The genome suggests something more active, an island that was itself a crossing point, a place where a specific ancestry took root early, took power later, and left a signature precise enough for a modern laboratory to trace back to a single legendary name. If you find this kind of investigation compelling, where a surname turns out to be a thread connecting a living person to a Bronze Age migration and a medieval dynasty at once, subscribe, because there is far more of this hidden in ordinary family names than most people realize. Scientists remain appropriately cautious about how far to take this. A shared Y chromosome lineage is not proof of direct descent from any one historical individual, and surnames themselves are cultural inheritances that don't always track biological ones with perfect fidelity. Adoption, name changes, and non-paternal events all complicate the picture. What the evidence does show, carefully and with real statistical weight, is that Irish population history contains at least one documented case of a specific paternal lineage expanding at a scale historians had no way of detecting from written records alone. The old map of Ireland told a story of invasions arriving neatly, one after another, each replaced by the next. The genome tells something messier and more human. A Neolithic population overwritten by a step-connected wave centuries before anyone called themselves Celtic, followed by centuries of internal expansion in which specific lineages, some tied to real, remembered dynasties, spread further and faster than any conquest alone could explain. The mystery has not closed. It has widened. Every new ancient genome recovered from a bog, a cairn, or a forgotten graveyard adds another layer to a history that was never as simple as a chronicle could make it sound. Somewhere beneath every Gaelic surname carried today is a thread reaching back through a medieval kingdom, through a Bronze Age migration, into a version of Ireland that existed before the island had a name anyone alive would recognize. That is not an ending. It is an invitation to keep listening to what the genome still has left to say.